This video is 12.4 day 3. We're going to continue the steps that we've been practicing with finding the derivative, and we're going to use that to find turning points on the graph. So what are turning points? First of all, they would be any max or mins or inflection points. So if we look at this graph, I see a max up here, a min down here, and I see an inflection point in there. So those are what we consider the turning points, and that's what we're going to be focusing on. So the procedure that we're going to follow is similar to what we've been doing. We're going to have to find the slope of the secant line. We're going to have to find the derivative. Now, we're going to have to go a couple steps further. So we're going to have to set the derivative equal to 0. So after we go through those steps that we've been working on and we have the derivative, that's when we're going to do some new steps, and we're going to take that derivative and we're going to set it equal to 0. And when we set it equal to 0, we're going to solve for x. And let's say the result is that x equals a. So a represents what we get when we solve for x, right? So then the next thing to do is to evaluate the function at the value that you just got when you solve for x. Okay? And let's say that when we do that, we get a result of b. Okay? So then when I ask you, well, okay, what's the turning point? That's going to be your x value and your y value. Okay, so there's your x value and there's your new y value, and that's going to be your turning point. All right, we're going to look at example 1 first, and we're following the steps that we've been practicing. So the first thing we need to do is find the slope of the secant line. This is the difference quotient, so this is f of x plus h minus f of x all over h. So we have 4 minus x plus h squared, and then minus all of f of x. 4 minus x squared, and then this is all over h. So this is x squared plus 2xh plus h squared minus 4 plus x squared all over h. 4 minus x squared minus 2xh minus h squared minus 4 plus x squared all over h. Okay, now everything should cancel that doesn't have an h. So I have a 4 with a negative 4. I have a negative x squared with a positive x squared. Awesome. And then I'm going to factor out an h in the numerator. I'm left with negative 2x minus h. So now my h in the top and bottom will cancel. So there is the slope of your secant line. All right, next step is to find the derivative. So f prime of x is when we take the limit as h approaches 0 of that slope of the secant. So if h is going to 0, that's gone. So this is just negative 2x. So this is your derivative. Okay, now here is where we have our new steps. So we have to take the derivative and set it equal to 0. So our derivative is negative 2x, and we have to set that equal to 0. When I solve, we get x is 0. Okay, then the next step was to take this value that you just got and put it into the original function. So now I have f of 0, which would be 4 minus 0 squared, which is just 4. So here's your x value, here's your y value, because it's the result after evaluating. So your turning point is 0, 4. Okay, let's look at example number 3. And the first thing we need to do is find the slope of the secant line. Here I'm subtracting f of x all over h. Now recall from the other video, we do have a binomial being cubed. So I still have that 2 out in front. So your first term is the x. That has the highest exponent of 3. Coefficient is 3 always as the second term. X decreases the exponent. We introduce the second term, h. 3 is always the exponent, 3 is always the coefficient, decrease the exponent for x, increase it for h. Increase for h. Okay, that's all just your cube and your binomial. I'm totally going to run out of room. So now I have minus 3x minus 3h minus 11 minus, oh boy, 2x. Okay, that totally looks awful, but we're going to keep going. Now I'm distributing the 2. And voila. So let's look at this crazy mess and see what can cancel. So I have a 2x cubed with a negative 2x cubed. The next term without an h is this negative 3x. It cancels with this positive, and then I have a negative 11 and a positive 11. Okay. So now I can factor out that h in the numerator. Voila, and those h's will cancel. So now we are left with the slope of our secant line. All right, so there's the slope of your secant line, and then the next thing we need to do is find the derivative, which is taking the limit as h approaches 0 of that secant line, which means everything with an h is going to go away. So what we're left with is 6x squared minus 3. There's your derivative. So now here's our new steps. We have to set this derivative equal to 0. So 6x squared minus 3 equals 0. So now I am going to factor out a 3. Still a 2 in front of there. Okay, and I'm going to divide both sides by 3. I'm going to add 1 to both sides. I'm going to divide by 2. So ultimately, I am going to be left with x squared equals 1/2, which means x is positive or negative square root of 1/2. And if I rationalize, I'm going to get square root of 2 over 2. Now, technically, we should find the turning point for the positive square root of 2 over 2 and the negative square root of 2 over 2. I'm just going to show you one of them. So the next step would be to evaluate into the original function. Remember, now this step takes us back to the original. And I'm evaluating at positive root 2 over 2. So I have 2 times root 2 over 2 minus 3 times root 2 over 2 minus 11. Oops, and that root 2 over 2 is cubed. So this is going to be 2 times 2 root 2 over 8. Minus 3 root 2 over 2 minus 11. And as we start to evaluate this, let's see, I have 2 root 2 over 4. And you know what? I'm just going to simplify that even more. That's going to reduce to a root 2 over 2. There we go. And then minus 3 root 2 over 2 minus 22 over 2. I just got everything with a common denominator. So this should be negative 2 root 2 minus 22 over 2. Since they are all divisible by 2, every single term, so this term, this term, this term, all divisible by 2, so I can simplify. So that's going to be a negative root 2 minus 11. Wow. Okay, so our turning point is our x value, which is root 2 over 2, and then the y value we got is negative root 2 minus 11. Okay, then you would want to do the exact same process, except you're going to change this to a negative root 2 over 2. All right, for the last example, I did some of the work for us. So we've practiced finding slope of the secant line and getting the derivative multiple times now. So I found that for you. So the next step to get our turning points would be to take that derivative and set it equal to 0. So we have 2x minus 6 equals to 0. So x is going to be 3. And then we take that x value that we just got and we substitute it into the original function. So I'm evaluating the original function at x is 3. So I have 3 squared minus 6 times 3 plus 7, which is negative 2. So now here's your x value and here's the y value that you just got after evaluating. So your turning point is 3, negative 2.